Okay, so here's the last lecture video that you're going to have to worry about this semester. And it's going to cover sections 8.3 and 8.4 together. But what I wanted to do first is review our steps for solving linear equations. So the first thing we got to identify, what is a linear equation? And remember, a linear equation is an equation where all the variables have an exponent of 1. It doesn't matter how many variables you have, nor does it matter how many different variables you have. If they're all raised to the first power, that is a linear equation. And right here are the 6 steps. So step 1, if fractions are present, multiply each term by the LCD to reduce all denominators. Step 2, if parentheses are present, use the distributive property to remove them. Step 3, now there's a star next to it because step 3 and step 4 are the 2 steps where we tend to run into issues because we're moving too fast. Slow yourself down and just follow the steps. Step 3 says to combine like terms on each side of the equation. So we only look at the left and then we only look at the right, and we combine like terms on each side independently. Step 4 is where you start moving terms from the left or the right hand sides. And we do that by using the addition or subtraction property of equality. The goal is to isolate the variable terms and constant terms to opposite sides. Step 5, we're going to divide both sides by the equation in front of divide both sides of the equation by the number in front of the variable. And then step 6 would be just to check our solution. So without further ado, I'm just going to go ahead and just do a bunch of examples. And then that's going to be it for this. So let's go right here. All right, so for this entire 2 sections or this entire video, the directions are simple. It's one word. Solve. That's it. So the first problem is going to be 7n minus 3 equals n plus 3. Okay, and off to the right here, I'm just going to write like my steps, like what did I do it? And this is just going to give me an idea. That way when I go back and look at it, I go, oh, okay, yeah, I remember. But hopefully, and if you haven't done so, I highly recommend go back to the beginning of the video, pause it, write down the steps on a separate sheet of paper, and then read them and follow along as I do these problems. So step 1, I do not see fractions, skip. Step 2, I don't see parentheses, skip. Step 3, I look on the left, there's nothing I can combine on the left. I look on the right, there's nothing I can combine over there on the right. Step 4, this is where I move variable terms to one side, constant terms to the other side. So for this specific example, I'm going to just pinpoint and highlight what do we have. So that's a variable term. That's a variable term. They need to be together on the same side. That's a constant term. And that's a constant term. They need to be together on the same side, and that has to be on the opposite side of the variable term. So steps, I'm just going to isolate variable terms and constant terms. So let me erase, and I'll show you how I do that. So the first thing, it doesn't matter what you move, and it doesn't matter what term you move. The only thing that matters, did you do it correctly? So if I look at this letter N, the sign in front of the N, remember, signs matter, is really positive. Okay, so it's really a positive N. And since N is positive on the right-hand side, I need to move it to the left, which is the opposite side, so I'll do the opposite operation. So I'm going to subtract N from both sides. That's going to give me 6n minus 3 equals positive 3. Now I am forced to move this minus 3 on the left-hand side. And that's because, remember, we got a variable term and a constant term. So this constant term has to move. So since it's negative 3 on the left and I want to move it to the opposite side, I do the opposite operation, which is add 3. That's going to give me 6n equals 6. So isolate the variable term and constant terms. Check, I did that. Now, step 5, I'm just going to divide both sides by the number in front of the variable. Divide by 6, divide by 6. If you look on the left-hand side, the 6 is reduced. They turn into a number 1. And on the right-hand side, they reduce, and that turns into a 1 as well. Now, normally, I don't write all the scratching. Normally, what I would do is I would just leave it as that right there. Okay? So there's our first example. Let's move on to the next example. And this next example, it's going to be a little bit more involved, but that's okay. So our next example is going to be 3 over 2, x plus 5 equals 1/2 x minus 3. Okay, now, for this problem, we're going to just go right over our steps once again. Nothing changes. That technique, those 6 steps, never, ever change. So step 1, if you see fractions, multiply by an LCD to eliminate them. So what I need to do is get my LCD and multiply to reduce, and this is the key, all denominators. Now remember, this is step 1, so if you have those steps written down, you know exactly what I'm talking about. So for us, it's really simple here. Our denominators are 2. So my LCD, and I'm going to write it over here on the right-hand side, it's just going to equal 2. Now, if you want to, just watch, then write it down. I'm going to take that 2. I'm going to write nice and neat, and I'm going to multiply every single term by that number 2. Okay? Now, the reason why I'm doing that is because I know when I go to multiply fractions, all right, I reduce first. Now, real quick, I'm going to show you, just to demonstrate, those 2's are really over 1. So if you think about it, you have a 2 in a numerator and a 2 in a denominator, and they're going to reduce. Okay? Let me use a different marker here so I can scratch them out. Remember, the whole goal is to reduce these fractions. Then you write what's ever left over. So in the numerator, I have a 3x. So I'm going to write that. Plus 5 times 2, well, that's going to be 10. Equals, notice you have a 2 in the numerator and a 2 in the denominator. They reduce, write what's left over. That's going to be 1x. Minus 3 times 2 is 6. So if you look at what we just did, in one step, we removed all of our denominators. Now we just go ahead and start doing our problem. Step 2, do I see parentheses? No. So I could skip it. Step 3, I look on the left. There's nothing I can combine on the left. I look on the right. There's nothing that I can combine on the right. So step 3 is done. Step 4, isolate variable terms and constant terms. So that's what I got to do here. So I don't care what you move first. All you got to do is pick something. I'm going to pick the 1x. So I'm going to subtract x from both sides of my equation. Now the reason why I'm subtracting x is because this x is positive. So 3x minus x is 2x plus 10 equals negative 6. So now I'm almost done with isolating the variable term. I did the variable term. Now I got to do the constant term. So I subtract 10 from both sides of my equation. And that's going to give me 2x equals negative 16. Check. Now I just divide both sides by the number in front of the variable. So I get x equals negative 8. Okay. So let's keep moving on here. Let's keep moving on. How about this one? Let's try this one. I like this one. 5 times the quantity, x plus 3 equals 35. All right. So step 1, do I see fractions? No, so you can skip step 1. Step 2, do I see parentheses? Absolutely. So I need to distribute. So I'm going to take 5, multiply times x, and 5 and multiply times 3. That's going to give me 5x plus 15 equals 35. All right, so step 2 is done. Step 3, I look on the left. There's nothing that I can combine. Then I look on the right, and it's only one number, so there's nothing I can do there. Step 4, isolate the variable terms and constant terms. So I look on the left-hand side. 5 times x plus 15 equals 35. Notice that my variable term is already on the left-hand side. So what I'm going to do is I'm going to take this positive 15 that's on the left, move it to the opposite side by doing the opposite operation. That's going to give me 5x equals 35 minus 15. It's going to be 20. So my variable term is isolated. My constant term is isolated. So now all I have to do is divide both sides by the number in front of the variable. And that gives me x equals 4. Okay? So let's try one more here. Let's try, 4 times a quantity, x minus 2 plus 5 equals negative 3. All right, so step 1, do I see fractions? No, so I can skip it. Step 2, do I see parentheses? Yes. So I'm going to have to use my distributive property. So I'm going to distribute the 4 to the x and the negative 2. That's going to give me 4x minus 8 plus 5 equals negative 3. Now step 3, can I combine like terms on the left? The answer is yes. So I'm going to put combine combine like terms, okay? And I'm going to combine the negative 8 plus 5. So that's going to give me 4x, and negative 8 plus 5 is negative 3, which equals negative 3. There's nothing that I can combine on the right, so I'm done. Step 4, isolate variable terms and constant terms. So if I look, my variable term is on the left. I'm not going to touch it. What I'm going to move is this negative 3 on the left-hand side. So I'm going to add 3 to both sides. That gives me 4x equals 0. So my variable term is isolated. My constant term is isolated. Now I just divide both sides by the number in front of the variable. So I just divide both sides by 4. So x equals, now remember, 0 divided by 4 you are allowed to do. So x equals 0. All right, so the next one, we're going to really step it up here. So we have 3 times the quantity x minus 2 minus 5 equals 4 times the quantity 2x plus 1 plus 5. All right, so here's my steps. All right, so step 1. Do we see fractions? No, skip it. Step 2, do we see parentheses? Yes, we do. We actually have 2 sets, one on the left, one on the right. So we're just going to distribute. So 3 times x is going to be 3x minus 6 minus 5 equals, then let's distribute the 4. So that's going to be 8x plus 4 plus 5. Okay? Step 3, combine like terms. The answer is absolutely here. We actually got to combine like terms on each side of the equal sign. So I can combine them. That's going to give me 3x minus 11 equals, and I can combine the 4 and the 5. So that's going to give me 8x plus 9. All right, so now that I combined all my like terms, step 4, isolate variable terms and constant terms. So it doesn't matter what you move, just move something. I'm going to choose the 3x. So I'm going to subtract 3x from both sides. We'll do that first. So that's going to be negative 11 equals 5x plus 9. And now I'm forced to move the plus 9 because I want to get the constant term on one side and the variable term on the opposite side. So negative 11 minus 9 is negative 20 equals 5x. So now my variable term and my constant terms are isolated. Next step would be divide both sides of the equation by the number in front of the variable. Negative 20 divided by 5, negative 4, equals x. Okay? So what I'm going to do now is I'm going to transition into more problems that have like fractions in them. Because we only did one so far, okay? And if you just follow, like I said, if you follow these steps that we have outlined, every single problem is done the same exact way, all right? So let's do about 3 more problems here. So the first one, 6 equals 1/2 x plus 2 over 5x minus 3 over 4x. All right, so I'm going to outline my steps here. So, step 1, do we see fractions? Absolutely. So we need to find an LCD. So to do that, underneath, I'm just going to go my LCD. I know how to find that. I write the prime factorization of each number. Okay? So 2 equals 2. 5 equals 5. And notice the big space I gave it. And 4 equals 2 times 2. So my LCD is going to equal 2 times 2 times 5. All right? So the LCD is going to be 20. All right? Now remember, the whole reason why we are doing this is so we can remove the denominators. Like, that is the goal. So watch how I approach this. I first found my LCD. Second, I'm going to multiply every single fraction by 20. So I write it nice and neat. I keep everything in order. Oh, sorry, wrong number. All right. Now I just multiply from left to right. 20 times 6 is going to be 120. Equals. Now remember, the goal is to eliminate denominators. So this is where my eyes go. My eyes go, first, I recognize that that's 20 over 1, and I'm going to highlight what I'm talking about. My eyes go right there. And the reason for that is because I know I'm going to reduce that denominator. So 20 divided by 2 is 10 times, and then you write what's ever left over in the numerator. So let me show you what's left over in the numerator. Right there, it's 20 times 1x. Plus, now I'm going to do the same thing. 20 divided by 5 is 4. So I write a 4, and I write what's ever left over inside. So that's going to be 4 times 2x. Minus, finally, the last one, 20 divided by 4 is 5. So I write 5 times what's ever left over in that numerator, which is going to be 3x. So notice here, I multiplied every single fraction by 20, and what that did is it eliminated all my denominators. So let me just finish this one right here. 20 divided by 2 is 10, and that's how I got the 10 times 1x. All right, perfect. So step 2, if you see parentheses, you're going to distribute. Well, I do see parentheses, so I'm just going to go ahead and multiply. So I get 120 equals 10x plus 8x minus 15x. Step 3, I'm going to have to combine like terms. Now, these are the terms on the right-hand side that I'm going to combine. They all have an x, and it's all raised to the first power. So 10 plus 8 is going to be 18 minus 15 is 3x. And you have 120 on the other side. Now, if you look here, my variable terms and my constant terms are already isolated. So I can put check marks right above them. Therefore, my last move is just divide. So I divide both sides by 3. 120 divided by 3 is 40. So 40 equals x. Okay? So I realize, big problem. However, if you look at the steps, and I'm going to just zoom out here so we can see it. There's step 1. Here's step 2. Here's step 3. Here's step 4. Here's step 5. And step 6 would be check, but I know I'm correct. So I'm just going to forego the checking for now. But like I said, if you think about it, every single problem is done the same way. It's just sometimes you use every single step. Other times you don't. So let's go ahead. Let's do a couple more examples here. All right, so let's move this up. We'll zoom in. Okay, so next problem. How about a plus 3 over 4 equals 3/8 a minus 1/2. All right, so once again, steps are the same. Excuse me, step 1. Do we see fractions? Absolutely. So let's find our LCD. So 2 equals 2, 4 equals 2 times 2, 8 equals 2 times 2 times 2. So my LCD is going to be 2 times 2 times 2, which equals 8. Now what we're going to do, we're going to multiply every single term by that number 8. So I just write it as such. All right, there we go. Okay, now remember, the goal is to remove denominators. So going from left to right, 8 times a is 8a. Plus, now remember, focus on the number in front, which is the 8, and the denominator. 8 divided by 4 is 2. And write whatever's left over inside the parentheses. So we got 2 times 3 equals. Now, 8 divided by 8 is 1. And write what's ever left over inside the parentheses. Minus 8 divided by 2 is 4. And write what's ever left over inside the parentheses. Now, we're just going to go ahead and distribute because we see parentheses. And really, if you really think about it, distribute is just another word for multiply. So I get 8a plus 6 equals 3a minus 4. Now, step 3, combine like terms. Well, there's nothing we can combine on the left nor the right. So what we're going to have to do is step 4. We're going to have to isolate the variable terms and constant terms. So like I said, it doesn't matter what you move. Just pick something and move it. So I'm going to subtract 3a from both sides because I like to get my variable terms first. 8 minus 3 is 5a plus 6 equals negative 4. Now I am forced. I got to move the 6. So since it's positive 6 on the left, I will subtract 6 from both sides. That gives me 5a equals negative 4 minus 6 is negative 10. And then I divide both sides by the number in front of the variable to give me a equals negative 2. All right? So I'd like to do just one more problem here. And this one is going to look a little weird, but remember, we got steps. Stay true to the steps. Don't deviate from them. So here's our problem right here. We have 1/5 times the quantity n plus 3 equals 1/4 times the quantity n plus 2. I give myself a little bit more space. There we go. All right, so let's start off with our steps. All right, so step 1, let's find our LCD. All right, so we'll do 4. 4 is 2 times 2. 5, remember, leave yourself a little bit of space. So the LCD is going to equal 2 times 2 times 5, or my LCD is going to be 20. Now remember, we are going to follow our steps. So step 1 says find the LCD and multiply multiply all the terms by it. So watch how I set this up. 20 times 1/5 times the quantity n plus 3 equals 20 times 1/4 times the quantity n plus 2. Now, we're going to multiply from left to right because that's the way we do it. So, I'm going to focus on the left-hand side here, and I notice I have a 20 divided by 5. So 20 divided by 5 is 4, and I'm going to write everything that's left over inside of the parentheses. Okay? Equals, on the right-hand side, 20 divided by 4 is 5. So I write 5 and everything left over inside the parentheses exactly how it looks. And just like that, in one step, denominators are gone. Step 2, we're going to have to distribute. So 4 times 1 is 4 times the quantity n plus 3 equals 5 times 1 is 5 times the quantity n plus 2. Now I will distribute the 4 to give me 4n plus 12 equals. Distribute the 5 to give me 5n plus 10. Step 3, combine like terms. Well, I don't have to do that here. Step 4, we're going to isolate the variable terms and constant terms. So I will move the 4n from the left to the right. That gives me 12 equals n plus 10. And then I will subtract 10 from both sides to give me 2 equals n. So my variable terms and my constant terms are isolated. And notice here, the number in front of the variable is a 1. So I don't have to even divide anything here. So my answer is n equals 2, which is fantastic. So that's it for not only this lecture, but for the entire semester. Please be careful, follow your steps. If you need the steps again, here they are. All right. Every single linear equation is done the same exact way using these 6 steps. Once you get really good, you can start to see things happening. But for now, I would highly suggest just use these steps. Good luck. Good luck on the final. And I will hopefully see you next semester. Bye.